Hello everyone, I'm here to help out today. So first I'd like to say that if I make a mistake or if you have any questions, leave a comment and I will try to answer it. So for today's question, we are looking at this. We have a Boeing 747 jumbo jet, has a length of 59.7 meters. The runway on which the plane lands intersects another runway. The width of the intersection is 27.7 meters. The plane decelerates through the intersection at a rate of 5.55 meters per second squared, and it clears with a final speed of 43.6 meters per second. How much time is needed for the plane to clear the intersection? So there's a couple things that we know with this. It gives us our acceleration. It decelerates, that is negative. We have a negative 5.55 meters per second squared. Its velocity its final velocity is 43.6 meters per second. The distance is, so in the picture, it gives us a picture right here. We can see that the distance is actually going to be this W, the width of that lane that intersects the other lane, the width plus the length of the plane. So X is equal to, I'll write it right here, 59.7 plus 27.7. We got that right here, 59.7, 27.7, and that should give us 87.4 meters. I'll go ahead and erase this, but that's how we got our X. So now we want to solve for time. This is what we don't know. This is the thing we want to figure out. And we also don't know our starting velocity. So this is a two-part question, so I will put this in there, and I'll start with the one right here. So when we look at our kinematic equations, every single one of them has V naught. So we can't really solve for time unless we have V naught. So when we look at this, we have our acceleration, our final velocity, and the distance. So we can go ahead and use our fourth kinematic equation, or V squared is equal to V naught squared plus 2AX. And we want to solve for V naught, so we'll bring everything to the other side, and we get V naught is equal to the square root of V squared minus 2AX. And when we fill everything in, we end up with 43.6 squared minus 2 times negative 5.55, and then times 87.4. Now that we have this, when we solve it and you put everything in, you should get 53.58, and this will be in meters per second. That is our V naught. So this is equal to 53.58 meters per second. When you're doing this, when you're putting this in your calculator, make sure to square this first, multiply these, and then subtract this value from this value, and then find the total square root of all of that. And then you should end up with this answer right here. So that's part one. We found V naught, and now this will allow us to find time. So going back here, we can use pretty much any of these kinematic equations. We're going to go ahead and use one because I find it to be a little bit easier. V is equal to V naught plus acceleration times time. So I'll go ahead and put that down here. This is part two of the question. And we're going to use V is equal to V naught plus acceleration times time. Now we want to isolate time because that's the variable we're trying to find out. So T is equal to V minus V naught divided by acceleration. And then we know V naught now, so we can plug everything in. We have all of these variables, and this is equal to 43.6 minus our newly found 53.58 all over acceleration, which is negative 50 or 5.55. And when we solve for that, we should get 1.7 seconds. So that's everything. I hoped that this has helped. This is a two-part problem, just like many other problems out there. I hope this helped. If you do have any questions, please leave a comment. And if this did help, please like the video so that other students know that this is accurate, and so that way we can help more students out there. So I hope this helped.